Excellent. Well, thank you very much, and I appreciate the opportunity to speak this evening. And very interesting listening to both Keith and Andrew's talks. I've certainly learnt a lot about the environment. Um, SeabedDC is a company that was set up about 3 years ago to tackle quite a key climate change problem. And that problem that we're trying to figure out is how do we build a sustainable digital world? How do we make sure the cloud, and in particular AI, is powered by nature rather than powered at nature's expense? The underlying issue we're all facing has been addressed already is AI and data centers are very much here to stay. They're transforming every aspect of society at an increasing velocity. But they're also consuming a vast amount of energy. And again, as pointed out earlier, the amount of energy used by data centers today is equivalent to the fourth or fifth largest country in the world. So a very, very large component of energy consumption is used in the data center and the cloud environment. So I'd like to look a little bit more closely at this environment and the overall size of the challenge. So today, the globally roughly 60, 70 gigawatts of data center capacity, and that capacity is expected to triple by 2030 with an enormous capital investment. And just about every evening on the news, there are very, very large numbers bandied around of AI companies making investments in data centers. But a number that is oft quoted is in the order of $6 trillion or more required over the next 5, 6 years to meet data center and AI capacity. That's an enormous quantity. That's more than twice the total GDP of the UK. At the moment, the percentage of data center capacity used by AI is relatively limited, probably between 15 and 20% at best. However, that demand is expected to grow extremely rapidly and to completely dominate AI and data center capacity or data center capacity by 2030 and the early 2030s. So this is very much or very heavily an AI-driven revolution or market change. Data centers are being built out very much as rapidly as people can, but there are some significant bottlenecks. And those bottlenecks are access to energy, access to cooling for data centers, and access to planning permission to build data centers. And as you can see in the small photograph there, we have a very large AWS, which is an Amazon Web Services data center in the US, located quite next to a large residential area, and that's not unusual. And they create interesting practical environmental challenges. The Data centers are enormous emitters of CO2 today. Some data that was issued by IAA relatively recently showed that data centers currently emit substantially more CO2 than the global aviation industry. So that's quite an interesting marker. Globally, data centers consume in the order of 2, 3, maybe 4% of global electricity, depends whose source of data you read. But if you take to certain extremes, Ireland, particularly the south of Ireland, data centers currently consume more than 20% of all electricity, and that's estimated to grow to around about 30% of all electricity by 2030 or thereabouts, an enormous percentage of energy of the society. Interestingly, one of the metrics that's increasingly used for the sophistication and advancement of a society is what the scale of data center activity is per head of population. And looked at from that perspective, the most advanced areas in the world or regions in the world are around the US East Coast, which is probably no great surprise, US West Coast, then Ireland, London, and certain large cities around Europe. Data centers are very much located around areas of high GDP generation. Not an enormous problem in the UK, but in many parts of the world, the large amount of water, and particularly fresh water consumption used by data centers for cooling, is a significant issue. It basically takes water away from local consumption, takes water away from agriculture. And that's proving a real issue for the expansion of data centers in warmer parts of the world. Most data centers today are currently powered by sources of energy that are linked to fossil fuels. Although most of the PR, the marketing work put out by the largest data center companies, very sensibly focuses on where renewable energy is used, the underlying problem is underneath these very large organizations, fossil fuels is still the dominant source of energy. So the issue around data centers is not just an engineering issue, it's very, very much an environmental issue. So what we at SeabedDC are setting up to do is to develop a next generation of cloud service, what we call a green AI cloud service. Very much a cloud service that is developed that instead of connecting data centers to very much overstretched grid networks around the world, we're connecting our data centers directly to sources of renewable energy. In this part of the world, that's very much offshore wind, onshore solar, and linking into battery storage. And instead of using fresh water for cooling, we're setting out to use seawater as our primary source of cooling. And instead of building large data center campuses on land near large urban areas, we're setting out to build our data centers located in ports and harbors, reusing ships, reusing brownfield industrial areas, and it's faster and cheaper and much less carbon intensive to do so. What we're really setting out to do is turning a global problem very much into a climate opportunity. So the architecture we're working with at SeabedDC is to build data centers in near to large ports, particularly deep water ports, harbors, or coastal areas, and particularly ex-industrial areas or large ex-industrial areas. And we're building two types of data center. The first is conventional data center technology, but built onto large repurposed vessels such as ro-ros, roll-on, roll-off ferries, such as the one in the image above. And second, we're building underwater data centers, data center modules placed in seawater. In both cases, we're using seawater as the coolant of the system. It's much more energy efficient than using air on land, and it's much more environmentally efficient than using potable water as our primary source of cooling. Together, the overall carbon footprint of building and deploying and operating these data centers is substantially lower than current data center technology. From a circular economy standpoint, we're setting out to reuse, to repurpose large vessels such as ro-ros and to repurpose industrial areas that are really otherwise fallen into disuse. The business model we've developed isn't just sustainable, but it's also very rapidly scalable. And over the next 10 years, we plan to build a network of data center hubs around the UK, Ireland, and Northern Europe, with our objective of building more than 1 gigawatt of data center capacity over the next 10-year period. To put into perspective, the UK currently has broadly in the order of 2.5 to 3 gigawatts of data center capacity. But it's estimated by the mid-30s, the UK will need 5 to 6 gigawatts of data center capacity, a very rapid expansion. Each of the data center hubs we plan to build out will hold between 100 and 500 megawatts of capacity, and these will be interconnected by fiber optic networks. Importantly, in the world, in the very challenging world we operate in today from a security standpoint, our data centers will be sovereign. They'll be located in country. We will have the ability to store critical data, key information within the boundaries of the country rather than have data center information distributed around the world. Each location we build our data center hubs will be an anchor for renewable energy investment. We will reuse existing facilities, port facilities. We will generate high quality, highly skilled jobs and drive investment into the regions, particularly around coastal areas. So basically, SeabedDC is setting out to deliver very much industrial scale decarbonisation of the cloud. And the business model we're operating with is much lower cost than conventional data centers. We're setting out to build an architecture that's powered directly by renewable energies, does not consume potable water, is very much driven around a circular economy and modular to wherever we reasonably can, and it's designed that we can scale very efficiently and quickly without being heavily dependent on grid infrastructure. Our business model sets out to strengthen the local energy economy and to secure new jobs and to accelerate the net zero agenda. And we're setting out to cool the cloud and the data center by the oceans rather than the water that's needed elsewhere on land. And we're proving that digital progress and climate change can very much be moved responsibly hand in hand. So what we're really doing in summary is to make the digital revolution part of the overall climate solution. So thank you very much for your time and very happy to answer any questions that you might have.